Let's say I want to write a function that will do the absolute value. I know we have a built-in one, but I want to do my own. So we'll call this my own absolute value function. And maybe I'll do another one that will do the cube root function. That's what I'm going to do here. I'm going to make my own function. IO, let's go. Since I'm going to be doing the cube root, that means I got to use the power function pound include CMath. And if you want to make your output really fancy, pound include IO manipulation. Before I forget, using namespace std. And now I'll begin my program. Now let's talk about the absolute value. So first we have to give that function a name. And it's gonna that function is gonna return a decimal value for me. An absolute value. The number could be positive, could be negative. So I gotta tell the machine that this function is gonna return a number for me, and that number is gonna be a positive number, and it's a decimal value. So I can write the function up before this one. I can put it there. I can say double absolute. I'm going to call it ZAB for absolute, Z absolute, ABS. So that's the name of the function. This function is going to expect a value from me. That value is going to be a decimal value. And let me begin that, and let me close it. And the way this function works, if what? If x is less than 0, then what do you want to do? You want x to be minus x. You can say minus 1 times x or negative x. That's the opposite. And return x. So when x is a positive, it's going to skip this one. If x is a positive, like 3.2, well, it's going to return the value of x, which is 3.2. But if x is negative 4, it's going to make it a plus 4 and return the plus 4. So that's my function. The name of the function is Z absolute. It requires one value from the main program. That value is a decimal value. And it's going to return one number that's a double. So right here in my main program, we'll say double num1 or num equals, let's say the number is, well, you know what? Instead of just num, I'll have the user enter a value. Cout and enter a number, any number, positive, negative, doesn't matter. Cn num, put it in that location, get some space, cout, and L. And now I'm going to call my function, but now remember, well, I need another variable that's going to have the answer in it. So here we go, answer equals, I need to call that function. That function is called z_ab, or absolute. And I'm going to send that number, the one I just took. This is how I'm going to call it. So it says call this function z_ab, take this value with you. So when you call this one, you go from here, you go right there. And whatever num there is going to be placed here. The machine checks that. And when it's done with it, it returns x, and x will be right here. The answer goes right here. So if I print the answer now, cout /n/n, give me 2 new lines. The absolute value of, and let's put the number here, num is, and answer, print the answer, and L. Let me save this one and let's run it. Enter a number, -50. The absolute value of -50 is 50. Run it again. 30. The absolute value of 30 is 30. Run it again. 0. The absolute value of 0 is 0. So it is working. Now let's do another function that will do the cube root. But this time I'm going to write the function right after this one, after the main program. Double is going to return a decimal value. I'm going to call this function cube with capital B, with C. And this one requires 2 numbers from me, double A, double B. It's going to require 2 numbers from me. Curly bracket to open it, curly bracket to close it. Actually, it's going to do the cube root of a number. I don't need 2 numbers, I'll need 1. Because the power is always going to be 3. So double R, which is the result, R equals the power function, the power of what? A to the power 3.0. And return R. That'll do the cube root. So here, after you print the absolute value of the number, let's find the cube root of that number. You can do the cube root of a negative number. So cout /n/n, 2 new lines. The cube root of num is and let's bring in the value. Now, if you want to get the answer for the cube root, let me get the answer here. I already printed the answer, so I can call it answer again. I can use the same one. Equals cube num. I already printed the answer here, so I'm okay there. So I'm just getting the cube root, I think I used capital C, and put the resultant answer. So let's print answer here. And L. When I run this, I'm going to have a problem with it. Notice it doesn't know what cube is. Why? Because your machine is sequential. Here it wasn't a problem because the machine went line 1, line 2, 3. Oh, it knows what this one is. So I know what that is. So, but when you travel here, there is no mention of cube till you get to this point. Well, cube is written down here. So if you decided to write it down here, you need to make a reference to it up there on the top before you enter the main program anywhere here. I can say double the name of the function cube, and this function expects a decimal value from me, double so it says there's a function called cube and expects a number. That's a double. Let's see, -8. Yeah, -8, that's supposed to be -8. The absolute value of -8 is 8, and the cube root, that's supposed to be cube root here, of -8 is -2. The cube. Oh, that's the cube. I didn't do the cube. I did the cube. If you want the cube root of -8, I will have to make the power parentheses here 1.0 divided by power of 1/3. That will do the cube root. Cube root. Let's call this function cube root. And let's call here cube root. I think I'm good with that one. Let's try -8 again. The cube root of -8 is not a number. 1 divided by 3 is 1/3. Doesn't like negative numbers. Not a number. Let's try the 8. The 8 should work, but doesn't like the negative number because it's using the square root function for the power. So whoever did the function power does not really accept negative values. So here's how to fix it. Doesn't like a negative number. We said, okay. If what? If a is greater than 0, then just go straight ahead and do it. Else, a, that means a is not bigger than 0. Could be bigger or equal to 0. You're okay if it's equal to 0. But if it's a negative number, what you want to do, that a equals -a, change it to a positive, use the power function, Use the power function to get it. And once you get it, change it to a negative, because the cube root of negative number is a negative number. So now that will take care of it. Make the number positive. Do the math because it seems to work on the positive number, then change the answer to negative. Let's save it. -8, that's when it gave us not a number. And here we go. The cube root of -8 is -2. So if the number is positive, go ahead and do it. But if the number is not negative, convert the number to a positive first. That's what this one. Do the power function, which only does positive numbers, not negative. And change your answer to a negative number. Try it again for -27. Should be -3 for -27. Cube root of -27 is -3. Run it. The cube root of 27 is a +3. So that's how you make your own function. If you write it after that statement, like notice I put this function down here, then I have to reference it up here. It says this is the name of the function. It returns a decimal value and accepts a decimal value. Notice I used X here, but I use A here. It doesn't matter. I could use A here. It will not make a difference. As long as you know, just tell the machine it's going to expect a decimal value there. -125. That'll be a -5, the cube root of that. There we go. Still works. I'll